This is Mr. Hassan's Maths channel, and I'm now answering question number 17 from the practice paper for the Cambridge 0580. This is the syllabus from 2025. This is from paper 2, which is the non-calculator paper. And this is a question about similarity. So it says triangle ABC is mathematically similar to triangle PQR. And we can see that they are similar even by just looking at them. These two angles have the same marking, so that means they're the same length as are these two. So therefore, angle, both these triangles are similar. Okay, and the length, they've told us that the length of AB and the corresponding length on the other triangle, one is 6, one is 12. So you can see that in terms of length, this bigger triangle is twice in terms of scale factor as the smaller one. And we know that the area of triangle ABC, which is a smaller triangle here, is 15 centimeters squared. And we want to find the area of the bigger triangle. All right, so that's what we have to do. So this type of question can be done in a couple of ways. I'm going to show you both ways, actually. Some people prefer one, some prefer the other. Both of them are perfectly fine. I'll show you both ways just so that people who are used to one way can relate to the other. So the way I like to do this question is as follows. I know the area of the smaller triangle. So I'm going to start off writing area that I'm looking for. It's going to be 15 times something. So it's going to be this number times something. Okay. Now I know this number has to get bigger. I know that this area is going to be larger, okay, than this area because it's on the bigger triangle. So I'm going to take the sides that correspond to each other on both shapes, okay, which is 12 and 6. They're the ones that we know and they correspond. They're in the same relative position. And I'm going to put the bigger one over the smaller one because I know that this fraction here is going to, if it's bigger over smaller, it will increase that number, and it has to increase it because the area has to get bigger. However, this is the ratio of the lengths and this is an area. If I want to find the area using ratios, I have to multiply by the ratio of the areas. Now the ratio of the areas is the square of the ratio of the lengths. So for lengths, let's call the ratio of the lengths K for similar shapes. For areas, the ratio of the lengths is squared. For volumes, the ratio of the lengths is cubed. The ratio of the length is cubed. Right? In this case, we have the ratio of the lengths, which is 12 over 6. And we've got to square that. Now, as we have a non-calculator paper now, before you just can stick this in your calculator and get the answer, it's better for you, obviously, to simplify this fraction first. 12 divided by 6 is 2. That gives you 2 squared. 2 squared is 4, so you're left with 15 times 4, which is equal to 60. Okay, 4 times 15 is 60. Lots of ways of doing that. You can do 15 times 4 if you're not sure. Okay, put a 0 here. 4 times 5 is 20, 4 times 1 is 4 plus 2 is 6. Or you can do it like this, 10 and 5. 4 times 10 is 40, 4 times 5 is 20. Add them together, okay? Or you can do it like this, 4 times 10 plus 5. They're all different ways of doing the same thing. 40 plus 20 is 60. Whichever way you do it, you get 60 centimeters squared. Okay, so there we have a few different ways of calculating in case you don't know the multiplication. Now, the other way of doing this is to say, okay, the area of the larger one over the area of the smaller one, okay, is the same ratio as, you can say, the length of the larger one over the length of the smaller one squared. The ratio of the areas is the same as the square of the ratio of the length, as we said. So the area of the larger one, okay, is what we're trying to find, over the area of the smaller one, which is 15, is equal to the length of the larger one, which is 12, over the length of the smaller one, which is 6, squared. So you end up with the same thing. You end up with the area of the larger one is equal to 15 times, and that's going to be 2 squared, which is 15 times 4, which is 60. So that's basically the same thing, but just a slightly different way of setting it out. Okay, so that is the area of the larger triangle. All right, so there's the answer to part A. Now for part B, it says the triangles are the cross sections of cross sections of prisms which are also mathematically similar. the volume of the smaller prism is 300 centimeters cubed. Calculate the length of the larger prism. So it's very important to read the question carefully here. They're asking for the length of the larger prism. Okay, this question, I'm sure many people didn't even read it and did the wrong thing. Here, so I've drawn a little diagram to give us an idea of the basically the fact that we're dealing with prisms now. Okay, so what we're dealing here is with prisms. So that's what I've drawn this diagram to show. Let me just okay, so these are again mathematically similar. Okay, and the volume of the smaller prism, so the volume of the smaller prism is 300 centimeters cubed. We've got to calculate the length of the larger prism. Okay, so we have the length here of the smaller prism, and we have the length here of the larger prism. Okay, so now we can do this in two ways. I could find the volume of the larger prism and then find the length. Okay, or I could find the length of the smaller prism and then find the length from here. Both of them would be perfectly fine. Okay, so I could find the length of this and then use the fact that this length is double that. Or I could find the volume of this and then use the fact that the volume is the cross-sectional area times the length. Okay, so either way is fine. Okay, either way is fine. In fact, I'll show both ways so that we can show both ways. So let me use one way first, method one, and then I'll do the other way just to show the different ways you can do it. So method one, I'm going to find this length first. So I know that the volume of a prism is equal to the cross-sectional area times how deep it is. So the volume of this prism we know is 300. Okay, 300 centimeters cubed. The cross-sectional area of this prism we already told was 15. We know that from the question. This is the same, okay, the same triangles we're talking about from the beginning. So A is 15 times L. So L is going to be 300 over 15. So we can see here that 15 goes into 32 times, you got an extra 0 there. So the length of this prism is 20 centimeters. So this is 20 centimeters. And I know that this length is going to be double this length. So the length that we're looking for is going to be 20 times 2. Okay, because the ratio of the length is 12 over 6, which is 2. Okay, so we could set it up if you want to in the same way as before. But we know the ratio of the length is 2, and this is the bigger length, so it's going to be 2 times. So we can say that the length of the larger prism is going to be equal to 20 times 12 over 2, so 12 over 6, sorry, which is 2. So 20 times 2, which is 40 centimeters. Okay, we could have also done it another way. I think that's an easy way to do it, to be honest. We could have done it another way. We could have found the volume of this prism. Okay, we could have said, okay, the volume of the larger prism is equal to the same volume as the smaller prism, but it's going to be increased by a ratio, the ratio of the volumes, which is 12 over 6, but cubed. Okay, so the volume is going to be 300 times, that's going to be 2 cubed, okay, which is 8. So you're going to have 300 times 8, which is 2,400, because 8 times 3 is 24, and you've got 2 zeros, 2,400 centimeters cubed. Therefore, we know that the surface area of this prism, or the cross-sectional area of this prism, we worked out to be 60. Okay, so this is, the cross-sectional area is 60. So we got V equals A times L. So we got 2,400 is equal to 60 times L. So L is going to be 2,400 divided by 60. They cancel out. 240 divided by 6 is 40. 6 goes in 24, 4 times extra 0. So we get the same answer. I think this is a much easier way of doing it. And why the advantage of this way is because we already have been given this area, that area we had to calculate. We could have got that wrong. If that's wrong, the next part's going to be wrong. So you want to get error carry forwards. Always use what you're given rather than what you have calculated. So that's one reason to use this, method, the method one here, because we know the volume of the prism already. We know the cross-sectional area of the prism already. They're given to us in the question. Okay, so it's much easier to work out the length of the smaller prism and then double it to give you the length of the larger prism. That's why this way is easier. This way, you're relying on a length or an area that you calculated. You might have made a silly mistake. That would be wrong. Therefore, this would be wrong. And you also have to calculate the volume of the larger prism, okay, from the smaller one. So that, again, there could be a mistake in your calculation for this. So this relies on two values that you have to calculate. Here, this relies on just one thing you have to calculate. This is a much more safe method of answering the question. If you did it this way and you got the right answer, you would get all the marks. I think this takes longer and is more risky. This is a much easier method of doing it. And I would tell you to stick to method 1 in such a question. So there's the answer to this question, number 17. I hope that was clear. Other questions from this particular paper can be found in the playlist that will appear at the top right of the screen at the end of this video. Other questions from the topic of similarity from the new syllabus you'll find in the playlist over here. From the older papers, which are before 2025, I'll collect all the questions here. And this question will be part of that playlist as well. So you can look at all the different styles of questions from before also. They will be very much relevant to what you get today, except in like, for example, see here, we have to use, we cannot use a calculator for any of this. So you have to understand before people would probably not even bother looking, doing any mental maths. So just put this in the calculator without thinking. Now you have to make things easier for yourself in your calculations. And you can subscribe to my channel by clicking on this link at the top. Thank you for watching and see you soon.